right, everyone, we are going to get started here. Hi, folks. So, welcome to Cleaning the Data. I am Chris Schott, a producer here at KDMC Berkeley. Our programs include workshops on topics like social media, data visualization, multimedia storytelling, and visual journalism. We also work with companies to help develop custom training programs with a focus on meeting the digital needs of your organizations. So today's mini tutorial is the first in a series of free online trainings we're developing on best data visualization practices, tools, and techniques to help you succeed in the digital landscape. So tell your friends and colleagues to join us next Friday for Demystifying the Data. Before we get started, just a few housekeeping items. We've got you guys all on audio mute because it gets a little chaotic with a lot of people all trying to speak at the same time. But we do have a few ways for you to communicate. Almost every window is going to have a question and answer box that you can type into if you have questions about the content. And we'll also have some chat boxes that are being monitored by Flynn May and Jeremy Lin, who are two of our media specialists. So thank you for joining us. I'm going to introduce our instructor to you. Peter Aldhous is a science reporter with BuzzFeed News and Data and a visualization instructor here at KDMC Berkeley. He teaches investigative reporting in the Science Communication program at UC Santa Cruz and has developed online training materials in data visualization for the Academy of Art University in San Francisco. Peter got his start in journalism in 1989 as a reporter for Nature in London, fresh from a PhD in animal behavior. Later, he worked as a European correspondent for Science, a news editor for New Scientist, and chief news and feature editor with Nature. His projects include web apps that have explored the local and global history of climate change and a number of Earth-like planets in our galaxy. So with that, we will get started. Sorry, folks, had a little audio problem here. There we are.
Hello. Apologies for that, people. So, I hope you can all hear me now. So, what I'm going to be talking about today is the hard work that often needs to be done before you visualize your data, getting it into the right format and cleaning dirty data before you can visualize it. So that's our topic today. Firstly, I'm going to talk a little bit about common data formats, because nowadays in the digital era, you may get data in different formats. I'm sure you're all familiar with getting data in spreadsheets. I personally like to have my data in text files, and particularly a form of text file called a CSV file. You're probably familiar with it already. CSV, separated values. Very transferable, can be read by just about any type of data analysis and visualization software. So here is some data in CSV format. It's just a few records or rows of data. We've got the field names across the top, and it's data on countries. We have their World Bank income group. We have their a rating of their level of democracy, and we have their historical prevalence of infectious disease for a few countries. You'll see quotes there. Quotes are delimiting or denoting values that are text, and they can be very important in CSV files because the commas separate the fields. Without the quotes, Bahamas and the would become separate fields. That will be a data cleaning problem that I talk about a little bit later on. So you may get data in that format. However, if you're getting data over the internet, you may see another couple of common formats as well, particularly if you're working with an API, an application programming interface. If you're using a URL to get data over the web from a web service, it may come back like this: JSON, JavaScript Object Notation. This is what it looks like. It's all wrapped up in square brackets, and each row or record in the data is wrapped up in curly brackets. And then we have these key value pairs. The keys are the field names, and the values are the values for those fields. They're separated by colons. You may also, when getting data from web services, find it comes at you as XML, Extensible Markup Language. Very similar, for those of you who are familiar with web design, to HTML, in that everything opens with a tag, here this row tag, and then has a closing tag at the end, denoted by the backslash or the slash there. So here's the same data. It's kind of similar to JSON in XML. Again, we have keys and values. They're separated this time by equal signs rather than colons. So what if you're getting your data, and you probably want to get it into a CSV file, that you're getting it as JSON or XML? Well, what can you do? Well, all of these URLs, by the way, will be available to you later on. You don't need to scribble them down. Don't worry about that. Here is a website that will allow you to take JSON, paste it into the top box, and it will spit it back out at you in a nice tabular form that you can make into a CSV file. If you have XML, and indeed if you have JSON, the main tool I'm going to show you later on will allow you to import those formats and export as a CSV. It's called OpenRefine. I'll talk about it a bit later on. If you find yourself needing to go the other way from a spreadsheet or a CSV file to JSON or XML, or indeed a whole lot of other data types, this can be a useful website for you. It's called Mr. Data Converter. It was put together by somebody called Sean Carter, who is a member of the graphics team at the New York Times. So Mr. Data Converter can be pretty useful. All right. I want to talk a little bit about the shape of data. This can be a very common task before you need to convert some data before you can visualize it. Data that's provided on many websites, often for download, looks a bit like this. I'm calling it wide. So this is time series data, years from 2000 onwards, for oil production in, I think it's probably millions of barrels or something like that, by world region, and it comes from the US Energy Information Administration website. And this is very easy as a table for people to read. You know, you read across and you see the data for each year. The problem is that most data analysis and visualization software does not want data looking like that. It wants the data in what I'm calling the long format, like this. So here, all of those production figures are now in a column by themselves, one variable per column, which is called production. All of the years, rather than being separate columns, are in years in their own column. One variable per column, long data. That's how most data visualization and analysis software is going to want it. I'll show you how to make this reshape in OpenRefine in a few minutes. Okay. I'm sure most of you are already aware of this, that there are two main flavors of data: categorical, which are basically just descriptive labels given to individual records, assigning them to different groups, and continuous variables, which are numbers which can have a range of values on a sliding scale. I've missed out date and time there, which is another form of data. But I particularly wanted to flag these up because of this. This is a data set which is actually about fatal and injury traffic accidents in the city of Berkeley. And this is the data as you would download it. It's actually compiled by the California Highway Patrol, and it is geocoded. It's got all the locations which have been applied by researchers here on campus at UC Berkeley. So this is the data as you download it. My warning here is that numbers in data are not necessarily numbers. Zip codes are an obvious example. They're not really numbers. You don't want to be running calculations on a zip code thinking it's a number. But we can see some numbers which are actually categorical variables stored as numbers. So day week is fairly obviously day of the week. It goes from 1 to 7. I think it starts Sunday to Saturday, but we can see later on. Crash sev is encoded by numbers which go from 1 to 4, 1 being fatal and 2 to 4 being various degrees of severe injury. But it's in there as a number, but you don't want to treat it as a number. You want to make sure that your software knows it should be treated essentially as a text value. So this can be an important data processing task before you think about visualizing, which means when you get a new data set, you're going to want to look at something like this, often called the code book, that really explains what all of these fields are and where numbers are being used to encode categorical variables. One is actually Monday for day of the week, and here's crash severity beneath it. So that you know what they are and you treat them the right way. You flag them up as text values, not as numbers. Okay. The big question when you get some data, can I trust this data? So just some rules of thumb on that I certainly apply as a data journalist. I want to know who's worked with this data before. Is this a data set that has been lovingly curated by professional researchers in the field? Has it been used for peer-reviewed publications? Or has it been put together probably with manual data entry because it has to be collected for some statutory reason? The latter type of data tends to have a lot of errors in it, and before you use it, you're going to do quite a bit of data cleaning. Always, if there are people who've worked with the data, I'm going to want to talk with them. I'm going to want to know its quirks, its limitations, and so on. Data cleaning is not something that can always be done just by looking at the data. Okay. Well, here is some dirty data. It's a data set I've worked with. It documents, well, it doesn't document all of them. It has a lot of missing data in it, but it is doctors who are running clinical trials, essentially, and registered with the Food and Drug Administration. That's what's in here. Yeah, if you can see this properly, you'll see that there are column B here and C is last name and first name. And I hope you can see that there is lots of garbage, percent signs and other symbols in those names. That needs cleaning up if you actually want to use that field in the data. This data, you can't see it on the screen, it also has dates in it. I found in there dates that precede the Norman conquest of the country of my birth, England. I've seen dates in it that haven't happened yet. Clearly erroneous data. And it's looking for that type of thing that we're going to be talking about and trying to work what we do with it with a very nice piece of software later on. Okay, some common problems with data. Let's just review some of them, and it's only some of them. Okay, we can see glitches in the alignment of columns that put data into the wrong field. That's if people have a CSV file and they haven't properly quoted their text fields and there's a comma in there, it's going to throw everything off. create a new field in one row where there shouldn't be one. A real bugbear for me in some of my projects has been variation in spelling, format, and accents, and just really variation in text fields generally, where things that are supposed to be the same thing are appearing differently. Names of people and places here can be a particular problem. And where I've worked on projects where I need to identify data to a person reliably, that can take a very long while to straighten out. Variation in date formats. Dates can be written in different ways. You want to standardize those if you're going to work and visualize date information. Numbers may be entered in the wrong units, or they may be entered incorrectly in all sorts of ways, but a very common one is sometimes people enter 1.5 million as 1.5 and assume the data is all in millions, and other times they write 1, 5 and a load of zeros. Those numbers, if they're supposed to be the same thing, you may see outliers in the data where the data has been entered in the wrong units. Some more problems you may see. Leading or trailing white space, I've written here, can be a real problem. Actually, extraneous white space anywhere. You can get double white spaces where there's supposed to be a single white space. And again, it'll cause real problems in identifying data that are supposed to be the same thing when it's a text field, but they won't appear the same way because of the white space errors. Numbers formatted as text and vice versa. So we're back to the issue I mentioned earlier about numbers are not always numbers, or you don't want to treat them as numbers, zip codes being an obvious example. Okay, and a big one, where you see zeros in the data. Are they really zeros, or are they actually no data, null? And this can be a big problem because as you move from one software application to another, you may find that null values, if you're not careful, turn into zeros. Now, if you're running calculations like working out the average, working out the median, plotting the distribution of the data, you want to make sure that your nulls remain as nulls. Okay. Before we go on to OpenRefine, I just want to mention one website here that can be useful for the particular problems of standardizing name formats. There's the URL. Again, it's from somebody else who works on the graphics desk at the New York Times called Matt Erickson. He has Mr. People. His colleague has Mr. Data Converter. Mr. People does one job. You can give it a list of names in all sorts of formats, and it will try and parse them for you, essentially into standard first name, last name, initials, prefix, suffix, and so on. Now, it is not infallible. I know from experience that it doesn't deal too well with Spanish family names. It doesn't deal too well where people have multiple suffixes. I'm a science and health journalist, so I write about people who are MD, PhD. MDs, PhDs don't get dealt with very well by Mr. People, but it's a very good first pass if you have a messy list of names trying to standardize them. Throw the list into here, do your conversion, get your output, and as long as you haven't resorted the data in the spreadsheet that you took it out of, you can paste it back in there, and you should be in better shape to carry on cleaning from there. However, for most of the rest of this session, I want to talk to you about a tool and demonstrate a tool called OpenRefine. OpenRefine was formerly known as Google Refine. It was a Google project that is now open sourced. If you do what I suggest and download the latest stable version rather than the development version from the link given there, it will still show up as Google Refine rather. And you will also get provided to you some links which have resources that go much deeper into this tool than I will be able to show you today. You can process and clean data in all sorts of ways. The very useful wiki, the full documentation, and the specific recipes for particular data cleaning and processing tasks should help you quite a lot with this stuff. Okay, so I now need to share my screen with you, and I'm going to hopefully sorry, we're just getting Chris to come in and give me a bit of help to find the right window here to share. There we have it. So apologies for that minor glitch, but now we are looking at OpenRefine, or as it formerly was known, Google Refine. Now you will notice that it has appeared in my browser. I recommend you use it in Google Chrome. If your default browser is another one, it will open in that browser, but just take the numeric URL and paste that into Google Refine. Into Google Chrome, and it'll probably work a little bit quicker there. So the first thing we need to do, we get this screen. By the way, it's in your browser. All your data is remaining on your screen. It's not being sent to Google. It's not being sent across the web to anybody. It's remaining on your screen. The browser is just a user interface for it. So you can bring data straight in from a URL if it's there. You can paste it in with the clipboard option. But I'm going to choose a file from this computer. So I'm going to click on this button, and I'm going to call in some data on Medicare spending in different counties in California, average spending per Medicare enrollee in a whole bunch of different categories. The data comes from something called the Dartmouth Atlas of Healthcare. So we select the file and we click Next, and you go to a preview screen. This shows you what's coming in. You will notice here that you can bring in Excel, you can bring in JSON and XML, as I mentioned, so you can use this as a data conversion tool. You can bring in CSVs and other types of text files. This shows you what's going to come in, so we can see that there's county name and there's codes for the counties. And then these are the figures in dollars for spending per enrollee in 2012 for different categories. This is going to be wide data because we want to create new columns of category and spending. But the first thing we need to do is to create the project. So we see a little preview of the data. We create the project, and here we are. By default, it shows you just 10 rows of the data. There's only 58 rows in here at the moment. I can expand and see more of it. So what we need to do is to collapse these columns into just two. So I'm going to go from wide to long, because if I want to visualize that, that's the way I need it. So I'll show you how to make that conversion. A lot of working in OpenRefine is just clicking on these little drop downs and then working out which option you need. Here we need to transpose, and I'm going to transpose cells across columns into rows. Okay, so I click on that and I get this little dialog box, and this tells me I'm going to start doing that at the first Medicare payment category, and I'm going to go through to the last column, or I could set it there, it'll be the same thing because that is the last column, and I'm going to turn that into two new columns. The first one is the key column, and that's going to be category, and that's going to take into it what is now the column headings on the columns in the wide data, and the value column I'm going to call Medicare spending or something like that. Keep ignore blank cells checked. Do make sure you fill down other columns if you're doing this wide to long conversion. If you don't do that, you will end up with gaps in the data for the columns that you aren't reshaping. Okay, so having set it up, I can just hit transpose, and now see we had just 58 rows. Now we have 347. We have the categories nicely set up in a new column, and we have the spending in a new column. This is now in long format, and I can export it and visualize it. Export is up here to the right. I can export in various formats. I can hit comma separated value, and it will just go down into my download folder. So for this particular data set, I'm done. I can finish. To go back to the open screen, I can just click on Google Refine, and now we can see that the project is in there, and I can come back to it later if I want. I'm going to create another project though. I'm going to choose a rather messier data set, which is here called UCB Grants CSV. It's a CSV file. So I'm going to select that, and I'm going to click Next. I'll get the preview of the data again. And see, this time it recognizes that it's a CSV file. It recognizes that the separator is commas. If it didn't, I could change that. So we're good to go. I can hit Create Project. Okay. So now we have, this is a somewhat bigger data set. It has 1,287 rows in it. And I'm going to show you now some data cleaning that you can do in OpenRefine. And a lot of this involves creating what are called facets. So let's find a column that we're going to clean up. This is, you can't see all of it, but it's the recipient city name. I should tell you what this data is. It is data from the website usaspending.gov. And it is grants awarded to UC Berkeley from the federal government in the year 2013. So that's what I've got here. That's what the data is. But this is a somewhat messy and dirty data set that I do need to do some cleaning on. Okay. So I'm going to go Facet. Now this is a text file, so I select a text facet. And all of the possibilities in the data appear over to the left here. You'll see we have city name Berkeley spelled correctly in nice proper or title case. We have 327, you might be able to see, of those entries. But we have a lot of other options which aren't basically the same thing. Okay, well, Berkeley Alameda, that's just the county, that's just the same thing. So I can edit them one by one if I wish. That's what I'm going to do here, and apply. And that then just goes into Berkeley. I'm going to assume these CCDs I don't need to worry about, and that they're just Berkeley as well. Obviously, I'd check out what CD to CD meant if I was doing this for real. I'm going to apply that. We have a misspelling of, well, we have two misspellings of Berkeley. One in uppercase and one in lowercase. So I can click Edit, correct both of them. Okay, that's looking a little bit better. Alameda is a separate city. It might be referring to the county, but I'll leave it. But we have this mix of cases. Well, that's pretty messy. But I can fix that pretty easily as well. So here I'm not going to do a facet. I'm going to go back to the same column and go Edit Cells and find Common Transforms. And this does a whole bunch of stuff which is really useful in data cleaning. It will trim leading and trailing white space and consecutive white space, which I mentioned being a problem. I don't have that here, but I do have the problem of case, and I want this all in title case. So I'm going to click that, and it all corrects. And now we've got that field cleaned up acceptably. Okay, I'm going to close that facet down. I'm done there now. Now I'm going to go to recipient name. And this is really messy. I'm going to make another text facet and see what's in there. And look at this. This should all basically say Regents of the University of California. That's where all the grants go to, but there's a mess. This is classic dirty data. A particularly nice feature of Google Refine or OpenRefine is this clustering option when you're in a facet. It will apply various algorithms that cluster things that look similar, that are strings of text, together. And you can experiment with these methods and these keying functions. We won't worry too much about what they are. I know, because I've done this before, that if I keep the method as key collision and the function as metaphone3, it'll capture all of the data and try and put it into 3 clusters. Well, I want it in 1 cluster, but that's easy enough to do. I just check them all. I just go to the top one and type in what I want them all to say, Regents of the University of California. Let's copy that and paste it into the other 2. And this is a rather simple cluster. Most of the ones you'll do are a bit more complex than this, and you won't be making them all the same thing. And then I can merge selected and close, and now I have 1,287 records that are all the Regents of the University of California, which is what it should be. Okay, so we've played around editing some text fields. We've seen the clustering function. Well, what about numbers? Well, we can look at numbers and look for outliers in numbers. So I'm going to look for a field which is federal funding amount. It's this one. This is a number field. Numbers and dates, by the way, show up in Google OpenRefine as in green. Text values just show up in black. Okay. All right. So I can create a facet again, but it's a number. So now I'm going to create a numeric facet. When I do, I get a little graph called a histogram of the distribution. And I can use this scrubber to look at outliers at each end of the distribution. So I'm going to go right over to the left. And I've now only got one. I've just selected the value far on the left. It's negative. It's a negative funding amount. Now that might be right. It might be that the university had to pay some money back to the National Institutes of Health because it had been overpaid in a previous year. I'd need to check that out. The general point in here is I can create a numeric facet, and I can use this scrubber to look at the extremes of the distribution, and then I can go and check those data out and see which ones are right or not, and edit them as may need to be done. Okay, I'm going to close that one down. Let's think about dates. So we have some dates in here. Obligation action date, starting date, ending date. Well, they're not actually being treated as dates. They're in black. They're being treated as strings of text. Now, let's say I want to standardize that into a standard date format. That's really easy to do. Just click on it, go to Edit Cells, go to Common Transforms, and convert it to date. Click on that, and now it has created all these dates into, if you're familiar with working with date data, this is the international standard for a date format. You can probably work out what's going on there. The T separates the date part from the time part, and the Z at the end just denotes the end of the string. So if I was doing this for real, I'd change all the dates to standardized date and timestamps so that they can be read by any software that knows how to handle dates. Okay, now we can facet on dates as well, using dates and times using a timeline facet. And just as in the same way, I can look at the extreme dates, or I can look at any particular part of the distribution and see if they're right. These are actually all fine. The dates are pretty good in this. But in my data set I showed you earlier that had those dates that haven't happened yet, this will be a very quick way of identifying those and being able to edit them if I want it. Okay. Right. Now let's look for some numbers which are actually supposed to be text. They're not supposed to be numbers. So I'm pretty sure there's going to be a zip code in here. Yeah, here it is. Principal place, and you can't see it, but it's principal place zip. And they're green, they're numbers. I don't want any software thinking those are numbers and trying to run calculations, calculate the average zip code. That won't make a lot of sense. So I want to make sure this is treated as text. Okay, that's very easy. That's one of my common transforms. Edit cells, common transforms, take it to text. It goes into black, it moves over to the left. That's now a text value. I'm going to show a few more rows. We still have a bit of a problem with this. It's not standardized, because some of these are the full 5+4 zip code, although they don't have the hyphen in you would usually expect. But some of them are only the 5-digit zip code. So let's say I actually do want to visualize this data later on by 5-digit zip code. I need a new column that is just the 5-digit zip codes. That's easy to do as well. I'm going to go edit column, add column based on this column. And here I get a dialog box that allows me to enter an expression. And there are all sorts of functions you can write here. And as you go away and read the documentation, you will realize that just about any sort of function you want to run on data, any sort of transformation you want to make, you can write an expression here to do it. I'm going to show you a very simple one to sort out this 5-digit zip code column. Okay, so let's just call it something simple like zip5. Value will take the value from each cell, and I'm going to write a simple function, substring. String is just a string of text. Substring, well, it's part of that string. So take the value, and then I'm going to go comma 0, comma 5, and close the bracket. And you will see I've got a preview of what it's going to do. So what's happening here? Well, it's taking this value, and the value has an index, and the index actually starts at 0 rather than 1. So it's saying start with the first one and go through until you get to before the one that is 5, which is the 6th one, and just give me that. So I'll just change it and you can see what it does. If I make this 2, it'll start at the 3rd value and give me that substring. But that's the one I want. So I can click OK, and it will now create for me a new column called zip5, which has all of the 5-letter zip codes. Now you probably realized looking at this that some of this you could do in Excel. Some of it you couldn't. That clustering will be difficult to do. The wide to long is a bit difficult to do in Excel. But this is I'm about to show you what I think is the real magic of OpenRefine. I'm going to click on this Undo Redo tab. I have here a complete record of everything I've just done. And if I click here, I can go back to any point in the data, which is really nice. That's the uncleaned version. Or I can go right to the end, and that's the version with all of the cleaning done. Whoops. Something strange has happened there. Let me go back to the beginning again. For some reason, there we go, don't worry about it. Okay. Alright. Not quite sure why I'm seeing no rows there, but I'm not going to worry about it too much. So, the really nice thing is that when you've completed all of your cleaning, you go to this Undo Redo tab, and then click Extract. What you get here, this is actually JSON again. We met that earlier, but it is JSON that encodes everything we just did. You can copy this you can save it in a text file and keep it on your computer, and the next time you get data that needs the same operations, and you don't have to do all of them, you can choose the ones you know you're going to want to use again by just checking and unchecking these boxes. You can do it again. So if I copy this and close this down, and let's say I'll go back to my create project, and now so this would be, if I've just brought in a new version of the data set, it would look like this. I can go apply, I can paste this in, and I can just hit perform operations. And I'm not quite sure, I've done something that I shouldn't have done, which is why I'm showing you no rows. But it'll go through to the end and repeat the whole operation for you. Once you have your data processing pipeline in place here, you only need to do it once, and it is a simple paste, press a button, and the whole thing will happen the next time you need to do the thing with the same data. So that's pretty much what I wanted to show you that you can do with Google Refine or OpenRefine. There is a lot more. I've barely scratched the surface. We'll throw it open to questions. I just want to highlight again some of the upcoming events. So if you want in-depth training in data viz, and we'll do a little bit of data cleaning as well. There are three two-day workshops coming up at UC Davis, March 19th to 20th, Loyola in Southern California, April 17th to 18th, and there will be one in Berkeley at a date to be defined. Next Friday, if you want to come back at the same time, I will be talking, what do I mean by demystifying the data? I will be talking really about how to extract stories and narrative from data using visualization. So basically interviewing the data to try and extract some stories from it visually. So that'll be our topic for next week. So I'm going to start sharing my webcam again so you can see me, and hand over to Chris to organize questions.
Hey, Peter. So we had a couple questions come in. You actually did a very good job of addressing some of these already. So one person had asked, what do you need this for that you can't do with Excel? Which I think you did a pretty good job talking about the facets and the clustering. But is there anything else that OpenRefine is really good at that Excel can't quite manage?
Yeah. Certainly the things I would highlight, I did mostly say. That wide to long reshaping, I don't know if you've tried to do that type of thing in Excel. It's easy to go the other way. It's called a pivot table. But to reverse pivot, which is essentially what we're doing in Excel, is not so easy. It's much, much easier in OpenRefine. The big thing for me is the ability to save the entire pipeline of all the operations you've done, and to have that available for you in future when you have data that needs similar processing, literally at the touch of a button. Now, if you're an expert programmer, you can write, you could write a script in Python or something to do that. Most people who play around with data don't necessarily have those skills, and being able to write your own script by pointing and clicking and manipulating the data, but then know that you have it saved and you never need to go through that whole process again with data that needs the same job doing to it, I think is very, very powerful. Yeah, one more thing. I mean, I showed you one function, a substring function on a piece of text. There is so much more you can do with this tool when you get used to writing functions. Just an example, and I didn't have time to show it here. I geocode data. If I have addresses and I want to turn them into latitude and longitude coordinates, I use OpenRefine to go to the APIs of Bing Maps and MapQuest open and haul back those geocoded coordinates for me. And again, I've got that saved as a little script in JSON. I just bring in my list of addresses, paste in my geocoding script, hit the button, and go. And I can go off and make a cup of coffee and sit down, knowing that my computer is doing all of that work for me. So I see it, it's particularly optimized for data cleaning and processing, but it is a great automation tool. Once you get used to the idea that you can save these scripts, you can make your life easier by automation. I believe in that. Playing around with data manually is not fun. Having it automated and having your computer do it is much better.
That makes sense. There was another question about the undo function, but I think you covered that one really well. Someone else was wondering where you can see examples or learn the Google Refine language that you typed out, where the information on how to do those code screens.
There's 3 links I gave you, which I believe will be made available. The wiki is pretty good. The recipes, if you have a particular data processing task, you need to get the function to do it, you will probably find it there. If you really want to go through the full documentation, you may find it. But there are also some helpful videos on the OpenRefine website that will take you through, in a similar way that I did, through some of the common data cleaning and processing tasks. You might check out the website of ProPublica and search for a project and look for the sort of how-to behind it. There's a big project, a big journalism project called Dollars for Docs. It's about payments to doctors that was done by ProPublica a little while ago. The data guy behind it was called Dan Nguyen, a Vietnamese name spelled Nguyen. He had to clean that data, and he did it extensively in Google Refine as it was then. And he wrote some pretty nice blog posts about how he did it. So I do recommend those to you, as well as the nice thing about that is you can see what they did with it. So you can read the stories and know what they did with it. And this was, they had to get this right. They had the big problem that I've had with some of my projects, is it was names of people. And names of people can be given in multiple ways. People with accents on their names may or may not put them in. They need to know how many of these John Smiths are the same person than a different person. And that was something that Dan organized all of that work in Google Refine, and he wrote some nice blog posts about how he did it. Sorry, Chris, I'm not hearing you well now.
Sorry, mic volume was turned down there. So that's good. That segues just into our last question we have here, which is someone asking about Mr. People, how it handles foreign names with accents. Is that one you have to look out for when you're using that? Also, I just want to point out the links to a lot of these things we're mentioning in our closing links box on the bottom of the page, and we'll try to send them out to you as well. So
yeah,
Peter, just Mr. People.
So Mr. People should deal with accents. It's not the accents that are going to be the problem, I don't think, from memory of using it. Accents in text fields can be a very big issue in data cleaning, and I didn't talk about it, and that is a whole can of worms called character encoding. It is, if you do anything with data, the character encoding of your text files will be the bane of your life. It's a big topic. My general recommendation is try and keep all of your files in a character encoding called UTF-8. That will not, I believe, be where Mr. People falls over. I think it deals with, as long as you haven't already kind of messed up the accents, it should process them through reasonably well. What it is not going to clean up for you is if you have a muller without the umlaut and a Müller, if you know what an umlaut does to a U in German. It's not going to fix that for you. But what it's going to do is just take a messily formatted name like Matt Erickson Esquire and Matt E. Erickson, and put what it thinks of the first name, the initial, the last name into columns, so that that's the job it does. It won't match accented and non-accented. It'll just spit them out the way they went in. The particular problem I was mentioning with foreign names is, and I've seen it with Spanish names, so Spanish names can have two components of the family name often. It will struggle to work out, is that two family names? Is one of them a middle name? What's going on? Those are the sorts of issues it'll have. And if you have Chinese names, and which can be sometimes written one way around correctly and sometimes written the other way around in an anglicized form, it's not going to fix that for you. That is, you're going to need further data cleaning. Names, I'm sorry to say, if you need to make sure that people are correctly identified in the same format, it's a lot of manual trudge, unfortunately. Just fully automating that is very, very difficult.